2008 destroyed wealth. 2020 reshaped the world. History suggests cycles don't happen randomly. So what might 2030 hold? By the end of this video, you'll understand what may be coming, how to protect yourself, and how to potentially benefit.
Hi, and welcome to the DKAW lecture on the 2030 Known Unknown Crisis. Today, let's start off with a little history lesson where we're going to look at the 2008 financial crash and COVID-19. So what actually happened during the 2008 financial crash? Well, taking it back, it all started with a house bubble where high loans were issued to risky borrowers. And because of that, eventually that bubble came crashing down as a result of failure to pay back banks and failure to refinance homes. As a result, property houses went down in value, US banks, hedge funds collapsed, there was a freezing the global financial system, and eventually stock markets crashed. So the macroeconomic factors affected was interest rate, economic growth, and unemployment, and also international trade and investments. Now, a little fast forward in a recent history was the 2020 pandemic. So how did a deadly virus cause a financial crash? Well, let's talk about COVID-19 economic edition. It all started when the market was very stable and everything was happening as it should. Consumers were spending, but then all of a sudden productivity was brought to a standstill. So there was a supply chain shock. And then all of a sudden there was a mass liquidity injection into the cycle. Interest rates went surging high. And there was a new reliance on technology, thus leading to the development of artificial intelligence, also known as AI. Macroeconomic factors that were affected was the mass GDP contraction, the financial volatility, and the surge in inflation. So this brings to interest as to what are the common patterns that leads to these black swan events. Well, first things first, there's an economic cycle where everything happens as it should, everything is spending and money is recycling. Then all of a sudden, something happens that can't be predicted. Excessive debt is made, risk misplacement, policy overreaction, and global interconnected fragility, also known as the butterfly effect.
A common link between the two historical financial events is that crashes don't come from obvious danger. They often come from what everyone ignores.
The current macro state of the 2026 edition. Well, first things first, it is projected that our economy will be stable. We're actually looking at a stable economic growth. In other words, the inflation should decrease, hence allowing trade and geopolitics to happen as it should happen, thus leading to money being recycled as it should be. We're also forecasting the physical and policy and debt to decrease in value. And this is all for 2026. But that is not the reality, because there is such a thing as a black swan event that can occur. Because in actual realistic terms, here are the potential threats that can occur. There is unaffordable housing, unemployment is on the rise. This leading to the AI bubble to burst, which means that even though AI is currently the product that everyone utilizes as a tool for their day-to-day, it might not be as substantial given that it only occurs between 3 major companies.
Although these are just the philosophical assumptions and may not be the reality, but here at DKAW, we see it as an opportunity to try and quantify the possibility of these events occurring.
So we're going to first try and quantify a black swan event, which is a very extremely difficult activity to do, but let's try. So we're going to start off with a normal or Gaussian distribution, which looks like that. So we have our two variables, which is probability and event. So our highest peak is the mean event, meaning it has the highest probability, so it's most likely to occur. The one on the left is least likely to occur, but our focus is on the black swan event, which is on the right, means the extremity of the event is extremely high, but the probability of it occurring is extremely low. So we're going to try and attempt to produce a probability in seeing this black swan event occurring by looking at a statistical analysis in R. So here's a little R code that we're going to look at. And when we run this, you can see that the probability does not work because it's extremely low. So the next thing that you do in statistics is to try and get some samples that we're going to use. So we're going to use 1,000 values. But because the AIC and the BIC is extremely high, meaning the model won't fit, we have to get more. That's why we're going to look at generating training data. And using that, we're going to try and see that if it fits a standard normal, which from our plots, it does. Our mean is at 99. But we're going to try and but the best way to see if it's a standard normal is to see the plot, and especially your QQ plot, meaning that most of them fit into the straight line. Hence, a standard normal, meaning your mean is 0 and your standard deviation is 1 might happen. So your block method is what we're going to try and look at, where we have 1,000 values and then we're going to look at 100 different blocks, and within each block will be 10 sample data in that, and then the highest value, you're going to look at the highest value. And from this, we can see that the maximum frequency was in 130, which leads us to, which is very good in our model, meaning that we can try and work with that. And then using our Bayesian fitting and your maximum likelihood method, I think we used 3 methods to try and fit them. So your first attempt is your maximum likelihood, and you can see AIC and BIC is still high. We want it to be low, so we're going to look at L moments, we're going to look at Bayesian fitting, so the Bayesian distribution. And from this, your DIC is still high, but your Bayesian is what comes next after all of that. But I think what helps us with all of this was the extreme value theorem that we used the Bayesian to try and fit it into. And we get another error again. Yeah, this is the reality of coding and doing statistical analysis in R. Always error, so I'm going to try and block that out with a hashtag to try and get what we're trying, to try and see the value. But after many attempts, we finally succeeded, and the results are as followed. So as mentioned earlier, we're gonna look at 3 different outputs, and here's the code. You can try and pause to just see if you can emulate the code. So you're gonna start off with a generalized Pareto distribution. As you can see, let's suppose X represents the extremity of an event occurring. If it's greater than 150, low, greater than 200 is 0.00213. But what we're looking at is a black swan event, meaning that the X is greater than 0. The probability is 0. But if you look at your extreme generalized Pareto evaluation, that one also does not work because at the end of the day, your probability is still 0. So what is the best way to look at a black swan is to create a refutation framework. Here's a R code again, but this is for next week, because what we're trying to do is to try and see what is the possibility that something like an extreme event based on the macroeconomic state can occur in 2026. And this is the tool that we'll be utilizing to quantify that, but that's for next time that we look at this again. So we're going to try and quantify the 2030 known unknown crisis, which is known as the Rhino, which means that this might happen, but because of climate change and high debt and geopolitics, this is information that might occur, but there's a high levels that it will occur based on what professionals have done. So we looked at the R code, and basically here we're just going to look at what is available online with the R packages that are available in R for us to utilize. And towards the end of this R code, what's going to happen is that we're going to look at all the macroeconomic factors that affect your financials. In other words, your investments, as much as it would for in 2030, so that you can see what are the steps that you can take. Again, our code doesn't run again, so you have to go back and see what's wrong with it. There's a lot of attempts that I did here. Take note, don't install packages all the time. So I think this is the final code that does run. So basically we're going to look at something easy, which is like a simple data test. And then we're going to look at we're going to add more factors in just to try and see whether our model is working, because then we can go off into seeing whether our comprehensive model will then work later on. So it's a very slow process. Yeah, I'm just putting everything out in the open to see the reality of coding, statistical analysis at the end of the day, and this is it. So we're going to try and use our simple analysis. It doesn't work, but this time it does work. So we're going to look at 15 different assets, and each of them have a specific weight and their value. So you're going to see, based on the macroeconomic factors, what is the resilience and your climate exposure, we see that they have a low value. Then we're going to look at a quick test, which should work. And from this, we can see that there's a lot of this going on. And this just highlights the importance of using data visualization in all of our statistical analysis, because anyone can just come in and see the numbers and see what's not happening and not bring any value. So it's very important to try and put your outcomes into a actionable results that we can look at. But I think here we can see your mean return. But what we're mostly after is our full comprehensive analysis, which now we can just try and see, and it's a negative again and it's not working again. Now it should work. Reality of coding hashtag. So from this we can see that your early warnings overview, number of assets is 12, resilience is 0.29, Average climate exposure is 0.47. Optimization results, but everything will make more sense and a complete analysis in our dashboard. So here's the gray Rhino risk analysis dashboard. As you can see here, every macroeconomic factor at our disposal is going to affect financials, but it's only financials where the supply chain risk has more advantage over the financials, which I found very interesting. And if we go down further, we're going to see that it's more so to do with the fact that the fragility of the Archilus in the heat map that I will make available soon. So the fragility of our heat map, the cyber incident that can happen, is a portfolio distribution where you recommend putting most into your medium risky assets, and your large and small assets are at risk based on what we predict will happen in the future. Then we looked at your stress scenario, and here's some recommendations that we can look at. So urgent sector exit, geographic rebalance, your cyber supply hedge, your resilience building, position consolidation, and your stress test protocol.
Thank you for joining us today. Please subscribe and hit the notification bell. Until next time, have a nice day, week, month, and year.